If x is equal to a times of cos t plus log of tan t by 2 and y is equal to a sin t, we need to find dy by dx at t is equal to pi by 4. So let's differentiate with respect to t. We'll get dx by dt is equal to a times of differentiation of cos is minus sin t, differentiation of log of tan t by 2 is 1 by tan t by 2 into differentiation of tan is secant square t by 2 into differentiation of t by 2 is 1 by 2, and here we can write dy by dt is equal to a cos t. So upon simplifying here, dx by dt is equal to a times of minus sin t plus, we can write here 1 by sin t by 2 divided by cos t by 2 into cos square t by 2 into 2. So which is equal to a times of, so here 1 cos t by 2, here it gets cancelled, and again 2 sin t by 2 cos t by 2, 2 sin t by 2 cos t by 2 is equal to sin t formula, so we can apply here sin t. So minus sin t plus 1 by sin t, which is equal to a times of 1 minus sin square t divided by sin t, which is a times of, so 1 minus sin square is cos square t divided by sin t. And now dy by dx is equal to, so we can write dy by dx is equal to dy by dt divided by dx by dt, which is equal to a cos t divided by a cos square t divided by sin t, means into sin t will get. So that we can simplify, cos will get cancelled here, sin by cos is tan t by 2. So we can write dy by dx is equal to tan t. And now we need to find dy by dx at t is equal to pi by 4, which is equal to tan pi by 4 is 1. So 1 is the answer for this question. Evaluate integral 0 to pi by 2 x plus sin x upon 1 plus cos x dx. So we can write here integral 0 to pi by 2 x upon 1 plus cos x dx plus integral 0 to pi by 2 sin x upon 1 plus cos x dx. Integral 0 to pi by 2 x upon, we know that 1 plus cos theta is equal to 2 cos square theta by 2, and sin theta is equal to 2 sin theta by 2 into cos theta by 2. So let us apply these two formulas here. So 1 plus cos theta we can write 2 cos square x by 2 dx plus integral 0 to pi by 2 sin x, we can write 2 sin x upon 2 into cos x upon 2 divided by 2 cos square x upon 2 dx. So that we can simplify here as integral 0 to pi by 2 or 1 by 2 times x into secant square x by 2 dx plus integral 0 to pi by 2. Here we can cancel 1 by 2. 2 gets cancelled here, and cos one term gets cancelled. So sin x by 2 upon cos x by 2 is tan x by 2. So we can write this is tan x by 2 dx. Now let us simplify it. So we can write here 1 by 2 Integration of x into secant square x by 2. Let us apply the FG rule. So we know that integral of FG is equal to f into integral g minus f dash into integral g, integral of. So here x into integration of secant square x by 2 is tan x by 2, the whole divided by 1 by 2, minus integral of f dash means differentiation of x is 1 into, and again integration of secant square is tan x by 2 divided by x by 2 dx. So over the limits 0 to pi by 2. So here also we need to substitute 0 to pi by 2 limits. And then minus plus integral 0 to pi by 2 tan x by 2 dx. So we can write this 1 by 2 gets cancelled here. X into tan x by 2 over the limit 0 to pi by 2 minus, and again here 1 by 2 times here. So 1 by 2 gets cancelled here. Integration of is not x by 2, only 1 by 2. So we'll be getting here integral 0 to pi by 2 tan x by 2 plus integral 0 to pi by 2 tan x by 2 dx. So these two terms gets cancelled. So finally left with only x into tan x by 2 over the limits 0 to pi by 2. So applying the upper limit pi by 2 into tan pi by 2 divided by 2 is pi by 4 minus 0. So it is nothing but pi by 2 into tan pi by 4 is 1. So the answer is pi by 2. So integral 0 to pi by 2 x plus sin x upon 1 plus cos x dx is pi by 2. Evaluate integral 0 to pi by 2 sin 2x into log of tan x dx. So 0 to pi by 2, let us apply the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So sine of 2 times of pi by 2 minus x into log tan of pi by 2 minus x dx. So we can write 0 to pi by 2 sine pi minus 2x into log of tan pi by 2 minus x is log of cot x dx. Say this is I is equal to the first part, and here 0 to pi by 2 sin pi minus 2x is sin 2x into log of cot x dx. So let us assume that this is equation 2. Now adding 1 and 2, adding 1 and 2, I plus I is equal to 2i on the left side is equal to integral 0 to pi by 2 sin 2x into log of tan x plus 0 to pi by 2 sin 2x into log of cot x dx. The same integral 0 to pi by 2 sin 2x is common. We can write log of tan x plus log of cot x whole dx. 0 to pi by 2 sin 2x into log a plus log b is log ab. So log of tan x into cot x dx. We know tan x into cot x is 1. 0 to pi by 2 sin 2x into log 1 dx. We know log 1 value is 0. 0 into any part is 0. So we can say the integral will become 0. So 2i is equal to 0, which implies I is equal to 0. So our integration 0 to pi by 2 sin 2x of log of tan x answer is 0. Evaluate integral e power x upon root of 5 minus 4 e power x minus e to the power 2x dx. Let us substitute e power x is equal to t. So on differentiating with respect to 2x, so we have e power x dx is equal to dt. So our integral we can write e power x dx as a dt. So dt upon under root of 5 minus 4t minus t square. Let us simplify this separately. 5 minus 4t minus t square we can write it as negative of t square plus 4t minus 5, or we can write minus of t square plus 2 into t into 2 plus 2 square minus 5 minus 4 is negative of t plus 2 whole square minus 9, that is 3 square, or this can also be written 3 square minus of t plus 2 whole square. So we can write integral dt upon the root of 3 square minus of t plus 2 whole square. So we know that integral 1 by root of a square minus x square is equal to sine inverse of x upon a plus c. So we can write here sine inverse of t plus 2 upon 3 plus c. So substituting back t is equal to e power x, so you can write sine inverse of e power x plus 2 divided by 3 plus c is the answer. Find the particular solution of the differential equation dy by dx minus 3y into cot x is equal to sine 2x. So we can write here dy by dx plus negative 3 cot x into y is equal to sine 2x. So it is in the form dy by dx plus p of x into y is equal to q of x, where the integrating factor is e to the power integral p of x dx, and the general solution we can write y into integral factor. So you can write y into integral factor is equal to integral of q of x into integrating factor plus c. So let us simplify, let us find the integrating factor. So here integrating factor is equal to e to the power integral minus 3 cot x dx, which is equal to e to the power minus 3 integral cot x is log of sin x, or this can also be written e to the power log sin x to the power of minus 3, or we can write e to the power of log 1 by sin cube x. And since logarithm to the base is e, we have the property of logarithms, so we can write this is 1 by sin cube x. So therefore the general solution we can write, we may write here y into integrating factor, that is 1 by sin cube x is equal to integral of sin 2x into 1 by sin cube x dx plus c. So we can write y by sin power 3x is equal to sin 2x, we can write it as 2 into sin x into cos x into 1 upon sin power 3 x dx plus c. So we may cancel here 1 sin x 2 times. So we may write y divided by sin cube x is equal to integral of 2 into cos upon sin will be cot x into 1 upon sin will be cosecant x dx plus c. So y divided by sin cube x is equal to integration of cot x into cosecant x is minus cosecant x. So minus 2 cosecant x plus c. And now when x is equal to pi by 2, the value of y is equal to 2. So that substituting 2 divided by, since we know that sine pi by 2 is 1, so sine cube pi by 2 is also 1 is equal to minus 2 into cosecant pi by 2 is also 1 plus c. So which implies c is equal to 4. So you can substitute here, substitute back. So y by sine power 3x is equal to minus 2 cosecant x plus 4, or we can write y is equal to 2 cosecant x into sine cube x plus 4 into sine cube x, or this can also be written 2 into cosecant x into sine x will be 1, so 2 sine square x plus 4 sine cube x, that is minus 2 sine square x plus 4 sine cube x is the answer. Solve the linear programming problem graphically. Minimize z is equal to x plus 2y subject to the constraints 2x plus y is greater than or equals to 3, x plus 2y is greater than or equals to 6, and x is greater than or equals to 0, y is greater than or equals to 0. So let us consider the first quadrant, because x is greater than 0 or y greater than 0, which belongs to the quadrant 1. Let us solve the inequalities graphically. So here we can write x upon 3 by 2 plus y upon 3 is greater than or equals to 1, which implies that x intercept is 3 upon 2 1 by 3 upon 2 we can mark here, and 3 y intercept is 3, so we can have the straight line passing through the point 0 comma 3 and 3 by 2 comma 0. And the shaded region, since the origin will not satisfy here, like 2 into 0 plus 0 is greater than or equals to 3 is false. So we can say this region will be away from the origin. So we can just shade the to the other side within the first quadrant. And the next line we can consider x upon 6 plus y upon 3 is greater than or equals to 1. We can consider this x intercept is 6 and y intercept is 3. So we can have the line passing through the point 0 comma 3 and 6 comma 0. So here is another line x plus 2y is equal to 6, and this is 2x plus y is equal to 3, and this is a shaded region. And here this shaded region representing, since origin is not satisfying here also, 0 plus 2 into 0 is greater than or equals to 6, which is false. So we can consider the shaded region will be away from this. So you may consider. So we got the open shaded region here, and the boundaries are, we can mark one point is here 0 comma 3, and here is another point 6 comma 0. So the shaded region of both the inequalities having the boundaries 0 comma 3 and 6 comma 0. So here the profit function z is equal to x plus 2y. Let us verify these 2 points. At 0 comma 3, z is equal to 0 plus 2 into 3, which is 6, and at 6 comma 0, we have z is equal to 6 plus 2 into 0, which is equal to 6. So both gives the same value. Both gives the same value. So let us identify whether it is having the solution or not. For this, we need to consider the profit function x plus 2y inequality x plus 2y, and the value is 6 here, so it should be less than 6. Consider the inequality. Consider x plus 2y less than 6, and the graph can be considered with the coordinates here x upon 6 plus y upon 3. So we can take 6 comma 0 and 0 comma 3. Here is a straight line, the same as the second inequality, and the inequality will not will satisfy the origin, that is 0 plus 2 into 0 is less than 6. 0 less than 6 is satisfying. So this inequality means the shaded region of this inequality x plus 2y less than 6 and our solution region both are not intersecting, means there is no common point in between these two, means x plus 2y less than 6 solution, and the inequality is what is obtained 2x plus y greater than or equals to 6 and x plus 2y greater than or equals to 6. There is no common point. There is no common point, and hence we can say that the solutions are the points existing on the line segment, existing on the line segment joining the 2 points, joining 2 points 0 comma 3 and 6 comma 0. Since there is no common point, we can say that the solution or the points will be existing on the line segment joining 0 comma 3 and 6 comma 0. So there are infinite solutions for this. Each and every point on the line joining these 2 points will give the minimum value. Okay. Solve the linear programming problem graphically. Maximize z is equal to 15x plus 15y subject to the constraints x plus y is less than or equals to 60 and 500x plus 100y is less than or equals to 10,000, and x is greater than or equals to 0, y is greater than or equals to 0. So here the second inequality we can also write 5x plus 1y is less than or equals to 100. So let us draw the graph. Since x is greater than or equals to 0, y greater than or equals to 0, so the graph must be in the first quadrant. So let us consider the points here. The first one, x plus y less than or equals to 60, we can say that x upon 60 plus y upon 60 is less than or equals to 1. So 10, 20, 30, 40, 50, 60. So here 60 is the point, 60 comma 0 x intercept, and here 0 comma 60 y intercept. So we can have the line. So the line is passing through these 2 points, and the inequality origin is satisfying 0 comma 0. 0 plus 0 is less than or equals to 60 is true. So we can say that the solution will be towards the origin. And another inequality. So here we can write x upon 20 plus y upon 100 is less than or equals to 1. So we can say that 20 comma 0 x intercept and 100 0 comma 100 will be on y intercept 0 comma 100. So we can draw the line. We can have the line passing through these 2 points. And here also we can say that 5 into 0 plus 1 into 0 is less than or equals to 100, which is satisfying. So we can say the solution will be towards the origin. So we can say this is the solution. And so we can have these common points. One is origin 0 comma 0 and another point is 20 comma 0 is another point. Say this is O, A, and here it is the point B, which is the point of intersection of the two lines. We need to identify it. And another point C 0 comma 60. So we can say point of intersection of the two lines here, x plus y is equal to 60 and 5x plus y is equal to 100. Solving these both, 4x is equal to 40, which implies x is equal to 10 and y is equal to 50. So 10 comma 50 is the point B. So we can consider these 4 points 0 comma 0, 20 comma 0, 10 comma 50 and 0 comma 60. Let us find at these points the profit function z is equal to 50x plus 15y. So we will get z is equal to 50 into 0 plus 15 into 0 is 0, and here z is equal to 50 into 20 plus 15 into 0, so which is 1000, and next the third one 50 into 10 500 and 15 into 5 which is 750, that is 1250, and the next z is equal to 50 into 0 plus 15 into 60, that is 900, so we can say 900. So among these 4 points we can say that at point B, means at the point of intersection of these two equations, will give the maximum value. So therefore, for the given LPP, maximum is occurring at, we can say the point B 10 comma 50 and maximum value is 1250. Okay. Two horses are considered for a race. The probability of selection of the first horse is 1 by 4 and the probability of selecting the second horse is 1 by 3. What is the probability that both of them will be selected? Only one of them will be selected and none of them will be selected. So let A be the event, selection of the first horse, and B be the event, selection of second horse. So that probability of an event A is equal to given 1 by 4 and probability of an event B is given 1 by 3. So since we can say that this experiment is like independent events, so we can write P of A bar, means not selecting the first horse can be taken as, so we can write probability of not selecting first horse, that is P of A bar, is equal to 1 minus P of A, which is 1 minus 1 by 4 is equal to 3 upon 4. Similarly, probability of not selecting second horse is equal to P of B bar, that is 1 minus P of B, which is 1 minus 1 by 3 is equal to 2 upon 3. And now for the first question, Probability of both of them will be selected. Probability of both of them will be selected can be considered as probability of A and probability of B. That is 1 upon 4 and again 1 upon 3, that is 1 by 12. And coming to the second case, probability of only one of them will be selected, which can be considered first selection of A event and probability of not selecting the second event, or probability of not selecting the first event or probability of selecting the second event, which is equal to 1 by 4 into 3 by 4, sorry, 2 by 3, 1 by 4 into not selecting the B is nothing but 2 by 3, plus not selecting the A is nothing but 3 by 4 into 1 by 3, which is equal to 2 upon 12 plus 3 upon 12, that is 5 by 12. 5 by 12 is the second answer. And third one, none of them will be selected. Probability of none of them selected, which implies probability of not selecting the first horse and again probability of not selecting the second horse. That is 3 by 4 into 2 by 3, which is equal to 2 by 4, which is 1 by 2. So 1 by 2 is the third answer. So the first answer, both of them selected, is 1 by 12, and second answer, only one of them will be selected, is 5 by 12, and none of them selected will be 1 by 2.